All right, so we are going to identify, by completing the square for the general quadratic equation, ax squared plus bx plus c equals 0, you can obtain the quadratic formula. I'm not going to actually do those steps. I'm going to, we're just going to know that you can get the quadratic formula from completing the square, which gives the solutions to the general quadratic equation. In the quadratic formula, the expression under the radical sign, this b squared minus 4ac, that's what we call the discriminant, okay? Its value determines whether the solutions of the quadratic equation are real or non-real. Right, it says when b squared minus 4ac is greater than 0, tell me, what does greater than 0 mean? What kind of number am I getting? Is that a negative number? Is it a 0? Is it a positive number? Tell me, what does greater than 0 get? All right, we are definitely understanding that that has to be a positive number. So when I get a positive number in the discriminant, that means I will have two real solutions, okay? When my discriminant is exactly equal to 0, that's where I get one real solution. So just to put it in context, two real solutions means I've got a parabola and it's crossing the x-axis twice, whether it's upside down, right side up or upside down, doesn't matter. If I have one real solution, that means it is bouncing off the x-axis somewhere. And then two non-real means I had a negative discriminant, meaning there was a negative under the radical sign. And that's the situation where I'm either floating above or floating below somewhere when I'm looking at a picture of a parabola. All right. Answer the question by writing an equation and determining whether the solutions of the equation are real or non-real. So they put this in the context of a word problem. I put like maybe 2 of these on the homework just to give you an idea. I think there were a couple that didn't have the word problem where you have to do the discriminant on the homework. And I threw a couple of completing the squares that hopefully have some eyes in it onto this assignment, since HMH wasn't working for me the other day. So a ball is thrown in the air with an initial velocity of 14 meters per second from an initial height of 2 meters. The ball's height in meters at time t seconds can be modeled by the quadratic function. So basically, we almost didn't need the entire 3 sentences here. They gave us the quadratic function. It wants us to know, does the ball reach a height of 12 meters? So the way we're going to figure that out is by examining the discriminant, because we know if we get imaginary solutions, that it would never reach that height. But if I can get some real solutions, we know that the height would be reached. So I'm going to take, first of all, I'm going to set this guy equal to, sorry, I have to know that it is equal to 12. Okay, so I'm going to set this height equal to 12. The height equation equals 12. In order to solve a quadratic, what does it have to be equal to? Can you tell me in the chat, please? So to solve a quadratic, what number does it have to be equal to on this side? Always. Good job. Oh, it's got to be equal to 0. So I'm going to subtract my 12 to the other side. So I have minus 10 equals 0. Now, if I'm solving a quadratic, the next thing I would really go for would be, is it factorable? And if not, I use the quadratic formula. But if they're not asking me to solve it, they're just asking me about the discriminant here. So this is the a value, this is the b value, this is the c value. Remember, a is always in front of your squared term. So I'm going to plug it into the b squared minus 4ac, okay, and decide if it's positive, negative, or 0. So I'm going to put my b in, which is 14. So 14 squared minus 4 times negative 4.9 times negative 10. All right, help me out. What's 14 squared? Tell me in the chat. What are we getting for 14 squared? All right, good job, 196. And then I happened to do this part here and I got a negative 196. So we are exactly equal to 0. So in this particular case, tell me in the chat, how many solutions do we have? And what type? So are they real, are they imaginary, and then how many? All right, I'm seeing some people saying 2 real. Make sure you're looking at what my solution is equal to 0. So I want you to go back to this chart and look. Is it a positive solution? Is it equal to 0? Or is it a negative solution? There we go. Now I've got some 1 real solutions going on. Good job. Okay, so it should be 1 real solution. I'm making sure I have the... okay, so it is 1 real solution. And then because we're going to be doing a book problem, okay, they also, but that really wasn't the question they were asking me. It says, does the ball reach a height? And it does if we have a real solution of any kind. So if you get 1 real or 2 real, the ball does reach a height. So yes, the ball reaches a height of 12 meters. And it would be because we have at least 1 real solution. All right, we're going to go on to the vegetable garden, right? All right, a person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by the function a of w equals w times 50 minus w, where w is the width in feet of the garden. Can the garden have an area of 700 feet squared? So we're going to go ahead and take our area and set it equal to 700. So I've got w times 50 minus w equals 700. All right. When I am looking at this and I have parentheses like this, what does instinct kick in and tell you to do right there? So what should I be doing with that w? Tell me in the chat. Good job. We're going to distribute. So we get 50w minus w squared equals 700. And again, you told me earlier that in order to solve for a quadratic, I would have to be equal to 0. So I need to move the 700 to the other side. At the same time I'm doing that, I'm going to move the w squared up front. So negative w squared plus 50w minus 700 equals 0. Now, in order to tell my yes or no answer here, okay, can the garden have an area of 700 feet? We're going to use the discriminant. So I've got my A, I've got my B, and I've got my C, okay? And I'm going to plug into the formula b squared minus 4ac. So tell me in the chat, what's the A value? I know my B value is 50, but my A value is a little trickier. What's the A value? Good job. We've got a -1 going on. And then we've got negative 700. All right, 50 squared. And you guys, you should always, hopefully, and it's okay right now if it's just your phone. It's amazing how much arithmetic I do on my phone. But I mean, if we were in the classroom, I wouldn't let you use that as your calculator. But if you've got a calculator, your phone, something hanging on, you should be checking my arithmetic as we go. I know sometimes I go fast, but because I do make mistakes, okay? We all are human. We all make an arithmetic mistake all the time, okay? All right, so -4 times -1 times -700, I got -2800, right? Because the negative times a negative times a negative would still be negative. All right, so I end up with -300. So tell me in the chat, how many and what type of solution do I have this time with a negative number? Go back to your chart at the top if you need to. Okay, so I ended up with a negative number. I'm going to come all the way back up here to my chart. When I am less than 0 or I have a negative, it tells me I have two non-real solutions, meaning if I were to solve this with the quadratic formula or with factoring, I would get i's. Okay, so this is two non-real solutions. You could call them imaginary solutions, that's fine. Okay, your book's is using the terminology non-real. So if I don't have real solutions, I cannot have a garden area of 700 feet. So the garden cannot have an area of 700 feet squared. That says feet. Leave it there a couple more seconds. All right, let's look at this next one here, okay? We will at least start it together a little bit. So it says, a hobbyist is making a toy sailboat. For the triangular sail, she wants the height in inches to be twice the length of the base in inches. Can the area of the sail be 10 inches squared? So they're expecting us to know a little bit of geometry. So we're going to see who remembers their geometry. So the first thing is that it says that we've got a base. I'm just going to call it B. Actually, I'm going to call it X. It makes our life easier later on if I call it X. Okay. All right, so I'm going to call the base X. Maybe. My device is a little behind today. All right, I'm going to call the base X, and it says that the height is twice the length of the base. So I'm going to call my height 2x. All right, so here's where the geometry comes in. It's telling us about the area of the sail. So we need a formula for area of a triangle. What's the formula for area of a triangle? Put it in the chat if you remember, or Google really fast. All right, Matthew, I like your thinking. You're thinking triangle. I think you got Pythagorean theorem. Anyway, no, oh, there we go. Now we've got an area. Okay. Do we have any agreement on that area? Just seeing if anybody else knows. Okay, so if you totally don't remember the area of a square or of a triangle, okay, you can always kind of develop it a little bit. Remember, we're talking about area, so we want the stuff on the inside, not the sides of it, okay? And Pythagorean theorem only works on sides if we have a right triangle. We don't know that this one's necessarily right. But if, say, I had a good old rectangle, hopefully we all know since elementary school that the area of a rectangle is base times height. All I do to create a triangle is cut it in half, okay? So it's either it's 1/2 the base times the height, or it's the base times height divided by 2. My thing that when I used to teach geometry many moons ago, okay? So you were all in elementary school, maybe, when I taught geometry last. I used to say if it starts with the T, you divide it by 2. Okay, so triangles and trapezoids, you divide by 2. All right. Okay, so let's use this formula here with what we have on our triangle to set up a formula and maybe get a quadratic going here. Okay, actually, I think we might do this one together because it's kind of ugly. All right, so area equals my base, which is x, times my height, which is 2x, divided by 2. They told us in the problem they want us to test to see if it equals 10. All right, On the left side of the equation, do we see anything that cancels nicely? Tell me what cancels. Put it in the chat for me. Good job. We see 2's canceling, right? So these guys are gone. Yay. We love it when we get to cross stuff out in math. I don't know what it is, but we love it. And then x times x is x squared equals 10. I don't know why. I'm going to drop this equal sign here. Now, we're going to still apply our discriminant rules to this, even though it's one where we would just take the square root of both sides to solve, right? I am going to, because of the nature of the problem, I'm going to subtract the 10 to the other side. And notice I left a big fat space in there, right? Because in order to use the discriminant, I need an A value, a B value, and a C value. Technically, if I put an X here, what number is in front of that X? Remember, the X wasn't there to begin with. I'm kind of adding in an invisible X. So what are we getting? I have one answer. Oh, we've got some other guesses. Okay, so actually Matthew is correct. There are 0 X's in this problem because I added an invisible X in. Okay, so my B value is actually 0 in this case. And sometimes we have to do that. We have to add that weird placeholder in there. We're just going to see that sometimes. All right, let's do our B squared minus 4AC now. So my B is going to be 0. Minus 4 times the A is 1, because that's an invisible 1 in front of an x squared, and we already had the x squared as part of the problem. And then minus 10. So the 0 squared goes away. Negative 4 times 1 times negative 10 is positive 40. So tell me, how many and what type of solution do we get on this one? Go back to the chart and look. All right, so if I look at my chart, I got a positive number. And when I have a positive number of greater than 0, that means I get 2 real solutions. So there are 2 real solutions. So that means that there is definitely at least one place, or that I would definitely be able to get a sale that had an area of 10 square inches. So therefore, the 3 dots means therefore. What was her name? Oh, the hobbyist. Okay. The hobbyist can make a sale of 10 inches squared. Matthew, it was a negative 4 times a negative 10, so it's a positive 40. Okay. All right. Now we're going to get it. We need a story, right? We need the story break. So let's talk quadratic formula, okay? There isn't a place for you to actually write down the formula, so put it over here in the left-hand column. So quadratic formula. Okay. Many moons ago, when I was first started teaching, so before you all were born, okay, is when I learned this story. So we're passing it down from olden times, right? Okay, let's see. We'll hit this button. Okay, so I've got out my good old PowerPoint, which I probably made, I don't know, maybe when you were born. Okay, so we've got the quadratic formula. In the quadratic formula, we've got a negative b. And this is actually, when you're talking quadratic formula, always start it with x equals. So x equals a negative b, okay? This negative b, he had a plus or minus chance of going to a really radical party, okay? When he got to the party, the B's were square dancing. And at the card table, they lost 4 ACs. The party was all over at 2 a.m. All right, so that's my, because I don't sing. You don't want to hear that. All right, I have no musical ability whatsoever. So that's how I tell the quadratic formula story. So the layer, you've seen the quadratic formula. This is not your first time on it. The layer that we are going to add is that we are going to put it in, we're going to have eyes, okay? So you're expected to know how to do the eyes with this, okay? All right, so we're going to try, I don't know, there's like 3 or 4 of these that we're going to make an attempt at here and see if we can, actually we might even get to skip one. So we're going to probably do about 3 of them, all right? So, oh, we might not even get that far. Let's see how quick we can go because I'm looking at time. We get out, is it 50 or 10? I can't remember. It's 10, isn't it? I get my times mixed up. So we have time. We'll do 3, okay? All right, so when using the quadratic formula, make sure the equation is in the form ax squared plus bx plus c equals 0. So our first one is definitely in that form. I am going to, on the first one at least, write out my formula. I would not expect the original formula be written out on a test, but I would expect to see you substituting into the formula one time or on the test, just to let me know, and not taking any shortcuts there, that you understand how to plug in, okay? All right, so in the chat, can you guys tell me what's the B value right now? I should see everybody doing this. That lets me know that you are paying attention and that you are understanding what I am saying, okay? That is a little bit better. There we go. I've got almost a whole page. Good. So we've got negative. And notice I have negative from the formula, and then I'm going to substitute in a negative 2. So the double negative is always going to go positive. Plus or minus the square root of. And I know that we could do negative 2 in our head. But on the one line, you're going to show me, and without simplifying it, okay? That way, you're demonstrating to me you understand how to plug into the formula, and that maybe the mistake you're making is arithmetic later on. Okay, the B value, I'm sorry, the A value, not the B value, is negative 5, right? It's in front of the x squared. And then the C value is the negative 8. And then we are all over 2 times the A value. Okay, so now we're going to do our simplifying stuff. Negative 2 squared would be 4. I have negative 4 times negative 5, which would be positive 20, times negative 8 would be negative 160. And then we've got 2 times negative 5 is negative 10. All right. 4 minus 160, I believe, is negative 156 over negative 10. All right, are you ready for it? Have you already typed it into the chat? When I see a negative under a radical sign, what do I need to do? Please tell me in the chat. Okay, we do in fact need to pluck our eyes out. That's what just added the Algebra 2 layer to this, okay? We wouldn't have seen that necessarily in an Algebra 1 class. All right, now I'm going to simplify that radical, which means I'm going to go down my list of square numbers. So I'm going to first test 4 into there. So I ask myself, how many times does 4 divide 156? It happens to go in 39 times. To be safe, I might check 9. Does 9 divide 156? I might check 16 to see if it divides 156, but none of those are working, and I know that 39 doesn't have a square number that divides it, so I probably have the biggest at this point. So from here, it's not that it's hard. There's a lot of tedious little steps, okay? And it's kind of a pain, all right? Which is why if I can factor something, I would factor it first, because I think that I could tolerate the magic X better than I tolerate all the fraction work and stuff that's here. So square root of 4 is 2. Typically, we put the 2 in front of the I, and then over negative 10. So the crazy part that comes in here, there's 2 ways I can do it from here. I could, if it was just me doing the problem, I would probably factor out a 2, okay? And then I'd be able to cancel it with my 10. Most students don't end up doing that way, so I'm going to show you the way that most of my students are usually the most happy with, at least from past experience. Typically, they like to split it into 2 separate fractions with the same denominator, which we are allowed to do. And then, because we're very comfortable simplifying a numerator and a denominator, right? Writing in a fraction in lowest terms. So 2 goes into 10 negative 5. 2 goes into 10 negative 5. So I have negative 1/5. Technically, what this negative, erase. Technically, what that negative does is it kind of flops the order of these signs. You will never see it written like that. It will only ever be written, at least not in our context, as plus minus. There are other contexts where it might be written that way. Okay. And then it's going to be I square root of 39 over 5. And again, the negative got grouped into the plus minus piece. Now, that's a perfectly good answer. We could also see the answer negative 1 plus or minus I square root of 139 over 5. Both of those are valid. Okay. Okay, let's do another one here and at least start it together here. All right, we have to be equal to what? So tell me again, what do I have to be equal to solve a quadratic? Put that in the chat for me. We were a lot quicker on that this time, so it's got to be equal to 0. Good. So I need to add 1 to the other side. So I've got 7x squared plus 2x. I'm adding 1, so it would be plus 4 equals 0. Okay, I'm going to put it into the quadratic formula. I'm not going to write out the original formula this time. My b value is the one in the middle, so negative 2. Can you guys tell me what the c value is this time? I know that a is 7, but what's c? Go ahead and type it in the chat. There we go. We've got a 1. Good job. My c value is in fact equal to 4, and then I'm all over 2 times the a value. All right, let's see how this one turns out. So x equals negative 2 minus, we've got 4 times 7. I forgot the square root, didn't I? What happened there, Mrs. Ballard? Plus or minus? And feel the headache coming on. So, all right, the staring at the screen headache. What did I do? I totally have messed this up, haven't I? Let me fix it. All right, so it's b squared, which is 2 squared minus 4 times the 7 times the 4. I wasn't paying attention. All right, so 2 squared is 4. Negative 4 times 7 times negative 4 is negative 112, all over 14. So we've got negative 2 plus or minus square root of negative 108. What am I going to ask next? Predict it. Put it in the chat. What did you think that put the answer to the next question I'm going to ask in the chat. What do you think the answer is? There we go. Okay, some of us have got my thinking down. All right, so when I see a negative under that radical sign, we know we are going to pluck our eyes out. Okay. All right, now I need to know the biggest square number that divides 108. What is it? Can you guys help me? What's the biggest square number that divides 108? All right, I'm going to start while you're trying to give me the biggest one. So I noticed that 4 does divide 108, but I also noticed that 9 divides 108. Has anybody figured out the biggest one yet? So I'm going to keep going. Does 16 go in there? Or 25? Or, ooh, look at 36. 36 divides 108 nicely. And if it was me, I'd be on my calculator going 108 divided by 16. Got a decimal, move on. 108 divided by 25. Got a decimal, move on. Okay, until I get it to come out nice and no decimal point. And sometimes I get lucky early, and sometimes I need to go a little bit bigger. So, but notice that 4 times 9, which both divide 108, is 36. So I'm going to use 36. And it happens to go in there 3 times. So I've got -2 plus or minus I, the square root of 36 is 6. Oops, I wrote that the way I didn't like to. All right, I am going to split it into 2 separate fractions. So -2/14 plus or minus 6I squared to 3/14. And then 2 goes into 14 7 times. We've got -1/7. 2 goes into both 6 and 14, into 6 3 times, and into 14 7 times. So 3I squared to 3/7. Perfectly good, 100% correct answer. However, you might see it written as -1 plus or minus 3I squared to 3 all over one single denominator, 7. All right, here's what we're going to do, okay? I am going to give you guys, we're going to start 9 together, and I'm going to give you guys a chance to work on it, okay? So I want to make sure we've got it equal to 0. I'm going to scroll to 9. We're going to skip 8. You can even write the word skip on there. So when I go to grade notes and you go to making sure your notes are ready to turn in, you know you don't have to do it because I told you to skip it, okay? All right, so let's look at 9, and I'm picking on 9 because it's not equal to just a number, it's equal to 2x. So that's a little bit weird and different. It doesn't work any differently than if it was equal to a number. So we want to get it equal to 0. We're going to subtract the 2x from both sides. So we've got x squared plus 6x plus 12 equals 0. All right, so here's what I want you to do. I'm going to give you about 1.5 minutes. I want you to get it started with your A, your B, and your C in the quadratic formula. Okay, so get it going, see how far you can get it simplified. All right, well, you're still working. I'm going to fill in at least my quadratic formula part. Okay, keep going, keep simplifying while I'm doing that. All right, let's see how we did, okay? So 6 squared is 36. -4 times 1 times -12. Hopefully you got -48 all over 2. So -6 plus or minus the square root of -12 over 2. You've already told me a whole bunch of the i's are going to get plucked out. What did you break? Tell me in the chat. What did you break the 12 into? What numbers? One of them has to be square. Remember that. All right, I'm seeing some 4s and some 3s. Okay, so square root of 4 is 2i squared to 3 all over 2. I'm going to split that into 2 separate fractions so I can simplify the fractions. I know 2 goes into 6 -3 times. The 2's cancel, so I just get plus or minus I square root of 3. Okay? All right, you do need to make sure that before you turn notes in, you are filling out your elaborates. I'm doing the best I can to get grades up by 3 o'clock. I know I graded a test just not too long ago, and I think I entered the scores for period 1, so you can kind of see what that's doing. I did notice this morning that every time I went and I include your warm-ups overnight, the system that's Otis, which imports your warm-ups in, takes them all out. So it's doing weird things to your grade, and I apologize for that. I'm just as frustrated as you are. So before I cut grades, so today after 3 o'clock, check your grade. It should be what it should be for the triad, okay, for triad 2. And we've got about 4.5 weeks to work on that, okay? So if you've got missing stuff out, make sure it's in. And then I don't know if I told you guys this or not, we're not gonna do a final exam in this class, okay? I'm gonna just have you retake a test or 2 that you didn't do as well on, okay? Rather than trying to prepare you for everything, we're going to comb it down and just prepare for something that you still are struggling on, okay? I hope that's okay that I'm not giving a final. I'm sorry if you were looking forward to a final exam, but that hopefully should motivate us to keep going, that we're not going to have to redo everything on the final, okay? I am going to really quickly, because we've got 2 minutes left. Let's see if we've got a joke. I don't know if he did a new one for today or not. We can always do the one he did for the other day where he looked up his nose. Let's see. Oh, he did do a new one for today. Let's see what Andy has for us.
So guys, I got a little thing to announce. Mom's ceiling is purple. Oh! I have no idea why Dad randomized it to be that color.
Because Mom picked it.
Anyway. So yeah, anyways, our joke today, there's a fine line between a numerator and a denominator, but only a fraction would know. I mean, understand.
There's a fine line between the numerator and denominator.
Well, here's another one. How are dollar and the moon similar? They both have 4 quarters.
Oh, I missed that one. I gotta do it again. What was it, Andy?
How are dollar and the moon similar?
Oh, a dollar and the moon.
They both have 4 quarters.
They both have 4 quarters. All right, you got 2 for 1 today, and you got to see the new purple ceiling. All right, you all. I will see you on Monday. Please make sure this is it for quadratic, so we're hitting review time. So I did put up an assignment. So today I will probably put up, hopefully I'll have some kind of a review. If not, it'll be a review activity of some kind of a catch-up day tomorrow. And then Monday we will sure have review. Probably Thursday, Friday, take a test on this. And maybe on the old stuff we'll retest. I got to look at it and get it graded, okay? And then coming in from after Thanksgiving break, we will move on to probably the next unit, okay? So I hope you all have a great day and a great weekend. I will see you all on Monday, okay? Alexa, play Christmas music.
Playing holiday classics music from Apple Music.